recording. Thank you, everyone. 3 participants who expressed interest in our machine learning study jam. And today, do you see my slides? We're gonna have a little bit of presentation and more coding, more demo. And by the way, if you haven't registered in the on the Bevy, on the community platform, I encourage you to register right now because it will help me to analyze the activity of my club. I'll appreciate. And now, so we will start with simple recalling. I don't know about your level of understanding of machine learning. So imagine we have a rock, paper, scissors problem, and in traditional programming, we provide data and some rules to get the answers. But you can imagine that there are many types of skin color, how people pose the different rock, paper, scissors shape, and it's difficult to define the rules so that we can teach a machine how to recognize the shapes. And in machine learning, we do the opposite. We provide data with answers and we extract the rules. So we can label rock, scissors, and vapors to identify the test data later on. So it helps us to distinguish these shapes. And imagine we have the simple example is having 2 arrays, X and Y. And do you know what's the relationship between X and Y? By the way, don't worry about wrong answers. Just unmute yourself freely and share your ideas. Do you know what's the relationship between X and Y? I'll help you.
Positive correlation?
Yeah, so, but there is a, like a, in mathematical formula, could you describe the relationship? So X and Y are related by this formula. We can see that when, so X increases by 1 and Y increases by 2. So if we take 0, for example, and the answer should be -1, so it could be like 2x minus 1. It's not important right now. I just want you to understand that if we know the relationship between X and Y, for example, in this position, sorry, I don't understand what Dev said. So if we know the relationship, how can we train a neural network to do the same as we do? So maybe if we have some more time, we could come up with this relationship, but how can we train the neural network? So actually we just parse the X and Y sets to machine learning and get the rules distinguished. First of all, I want you to know that we will use TensorFlow, and this is the Google Brain team created open source library for machine learning and other computations. And the framework for defining a neural network as a set of sequential layers is called Keras. So the simple model could be depicted as a neuron. It actually was taken from a book. So we have some inputs and we get the output, and the more complex neural network is depicted on the right. So we have more layers, sequential layers. Okay. So let's do demo right now. I'll switch the sharing screens. If you have any questions, you're free to ask anytime. Okay. Hi, Abdullah, just saw you entered. We will use the collaboratory that provides the platform to run our machine learning algorithms. And I encourage everyone to open and do the same things along with me. So once you open this collaboratory, there are lots of text, and this is not important for us today. We create a new notebook. So this is where we will start our journey. And first of all, we will do the simple machine learning training and predicting using the same X and Y arrays. So we need to import the TensorFlow, the library, and we do it by import TensorFlow as TF. Then because we use the arrays, we need a NumPy library. I hope you are familiar with it, but if not, it's easy to understand. I will explain details. And then we need to import the keras. Okay. And now we need to define our model. So it's going to be the using the TensorFlow, and we use sequential. So if you don't understand some things right now, don't worry.
Sorry, can I ask something?
Yes, sure.
So you have import TensorFlow STF, but below you import TensorFlow from TensorFlow import keras. I mean, is that necessary, or why do you import two times? So thank you.
No, you can I think do the like this as well.
No, I mean keras will be already imported, right? No.
So
Okay, just continue.
oh, I'm not sure. I want to try it as well. I think you need to import it. Okay. And we define our model here. So we put layers, and because we have only one neuron, we will have units equal 1, and we will have the input shape. The input shape is also 1. So we get only 1x to the input. And now I think, okay. So we need to, we define the model, but we need to build it. So we use compile, and we need to provide two functions. On past study jams, we discussed about the loss, calculating the loss, and briefly, it's so when the model predicts, the difference between the prediction and the correct answer is the loss, and it will be calculated. And we need to train the model to minimize the loss. So we provide two functions, which is the loss and optimizer. The optimizer will, after calculating the loss, optimizer will provide the next prediction, and it will loop several times as we define it. And for now, the optimizer is the SGD, and I think I have some notes. So the SGD is the stochastic gradient descent, and we also covered this on last study jams. So we want to reach the minimum loss by step, and we do it by gradient descent. So the optimizer is SGD, and we define the loss, which is mean squared error. If you use anywhere the linear regression, maybe you know the mean squared error. Okay, now we defined and build our model, and let's create the arrays using NumPy. You can use other numbers if you want. I'll try to just use the ones in the tutorial. So we saw already these numbers in the presentation, and y is, so NP array, for those who don't know, that's how we create the arrays. It's -2, 0, -1. Actually, it's going to be a different formula. And then, okay. Now let's train the model, and we do it by .fit. We provide x and y, and the number of epochs is the number of times the model will be run, the function will be run. Okay. So I'll define here epochs. And it's going to be, let's do it 500 for now. Now let's print the model prediction. So any number you want, we use .predict to predict the outcome. So let's do it like 110. Run the code. Okay, there is a mistake here. Yes, we need to use TensorFlow. Okay, what are other mistakes? Okay, I think we need to provide the type, maybe. Format. Numpy array. Ah, I see. And here, so many mistakes. Let's see. X, Y, and epochs. Interesting. Mean squared arrow. Okay, we run it. Now we need to wait until 500 epochs are completed. And I think this is resolved. So we need to import keras from TensorFlow. Okay, so we have 31. And actually the exact relationship between X and Y was the function that I have provided in the presentation. So it was 3x plus 3x plus 1. Any questions about this algorithm right now? So we imported TensorFlow, the keras, and NumPy to define our arrays. We created the model. We defined the model. We built the model by compiling it, providing the optimizer and loss functions. We trained the model with X and Y, defining the number of epochs, and we predicted what would be the number, what would be the X, the Y value given the X. Okay. So I will close this for now, and let's go to presentation again. And so this was the simple use of the neural network machine learning algorithm. We defined the relationship between X and Y. And now we will try basic computer vision problem with ML. So this will be the part 1. Imagine we have a data set and we want to identify the shoes. So shoes can be of different forms and different colors. And we need to provide, to identify the shoes from any data set, we need to provide the training data set that consists of different forms and different colors of shoes. And the dataset we're going to use is the fashion MNIST, which is built in the keras, and it comprises of a big amount of images, which are all of 28 by 28 of size. And there are 10 categories. Now let's do the same procedure that we did with the X and Y algorithm. Let's create the new file, new notebook. And the first thing that we're gonna do, could you remind me what I need to do first? Okay, while it runs, okay. So I want to create a machine learning that predicts the category. So there are 10 categories in the data set, and I want to predict what category does the item belongs to. So this is what my problem, and I will need to create a machine learning algorithm. What I need to do based on the first example. Can you speak louder?
Import TensorFlow.
Right, import TensorFlow. Then anytime we import TensorFlow, we know that from the definition, the framework for defining a neural network as a set of sequential layers, so layers of neurons, we use keras, right? So it's called keras. So anytime we import the TensorFlow, we need to import,
Yes.
right, so flow import keras. Perfect. Now we need to load dataset, and I said that the dataset we use today is already built in the keras. So we're gonna name it as data, and it's going to, we need how to load the dataset built in keras. We use keras dot datasets dot, and the dataset name is fashionist. Okay. Now I will write here the command that we load dataset and define training data. So let's define it. We didn't define it yet. So we define it by training images. And we have the training images, the items, and the labels, right? And then we also have the test images. Test images and test labels. And to define it, we use the load method on our data. Okay, so we defined our training images and the test data set. Now, if we want to see what the data looks like, let's import the matplotlib. And plot the training images. For example, the first one, let's do it. Okay, so I have a lot of sessions going on here, and it's too much. Okay. Leave. By the way, this is the website, very useful. Okay. If it runs on your computer, what do you see when you plot the images? One image.
Array.
Array, right. Now, oh, it's a tensor. Okay, TensorFlow. Yes, it's an array, and I have some mistakes here. Training images, training labels, no data. Okay, so I have this kind of image, right? So it's a shoe. Do you see the same? So we can try different shoe.
Oh, where was the error?
Oh, you had the array?
No,
Oh.
no, I had error.
Error.
That same. Yeah.
As me, yeah, because I had the arrow. So make sure you
No,
spell.
this one was right. TensorFlow was right in this line, training images and label. Something wrong is in this line.
Yeah, because I wrote load. I forgot load data. So the method should be load data. Make sure you write it like this. If you still have mistake, please let me know. Now, this image is actually an array of numbers. So let's see it. Training data. Training images, right? We have training images. And it's fifths. Yeah, so it looks like this array. And if I want to print the label, just to see what is the label for my training data number 5 or 6 training label. Labels, I think. Okay. Okay, so we see here is 2. It belongs to the second group, second category. Okay. So we don't need this anymore because I just wanted to show you the data we have. Okay. And let's go further. Now we see here it was useful to see the array of these numbers, and you can notice that they are from 0 to 255, I think. And it's always, not always, but it's useful to normalize data from 0 to 1, and it's easy to do. So let's do the normalization. And we just divide our training images, training images by 255. Okay, and we also do the same for the test images. Now we have our data loaded and normalized. Let's define the model as we did before. Does anybody remember how we do it from the previous example? No, okay, let's do it together. So we do tf.keras.models sequential. Now here we're gonna have a different parameters here, and I will explain it a little bit. So before we had just one unit, so one neuron and one unit shape, right? One input. But now we have here different layers. So we first need to define flatten. We can define it just like this. It would be enough. What it does is, so we have images of 28 by 28 size, and we need to convert it to 1D. So instead of doing a lot of defining the functions and so on, we use this flatten function that does the jobs for us. It converts 28 by 28 to, if you multiply 28 by 28, it's going to be 784 by 1. Okay, you can write here the input shape that actually we have. So we can provide the info that we have 28 by 28 images. Okay. Now we also need to define the dense, and now we will have 128 number, and I will explain it in the further exercises. Let's just keep this number. Activation, value, okay. And also another layer. And we will use 10 here, and I'll explain a little bit later as well. Softmax, okay. So we defined our model here, and we need to build model. By compiling. So I already give you a hint. So we build the model by compiling it with an optimizer and loss function. Do you remember how we do it? This is the main thing that you need to use. Okay, so we use compile, compile, and now we need to define optimizer. And in this case, last time it was SGD, and now we have a different one. because it's just basic computer vision tutorial demo, I'm not going to explain all of this, just enough to understand how to build and run the program. So now this is the optimizer function defined, and loss is the sparse categorical so it's something entropy. Okay, and we want to evaluate our accuracy, so we define the metrics. Okay, now I think this is the time for me to explain these parameters a little bit. So dense is so here we add layers, and we can imagine, do you see these slides now? Okay, I'm not sure if you do see slides. Can you see slides right now?
Yeah.
Yeah, so we have here 128, so this is the layers number, and activation is the activation function for our neurons, and ReLU stands for the something rectified linear unit, so it's written here. And what it does, it filters the output. So if the output is more than 0, then we return it. If not, we just get rid of it. And another activation is here, and it is softmax, that picks the biggest number in a set. So after the output, we get the probability that the input belongs to one of the categories, and it picks the maximum number, which is 9.78 here, and it will transform this array to 0 to 1. So any other minimal numbers are going to be 0, and the max number will be 1. So that's how it will define that the item that we got, it belongs to this category. So it's the 9th category. And that's all for the activation functions. And we will play with these numbers later on. For now, let's just use it like this. So we defined and built our model. Let's train our model. And how do we train model? Anybody, do you remember? We use the dot field fit, right? And we provide the training. So last time we provided X and Y's. Now we provide training images and training labels, right? So instead of X and Y, we have training images and training labels. And we define the number of times it's going to run. So let's do 5, because it's a much bigger data set than we used before. And I think maybe now it's not the time to run the program yet. Let's evaluate our model. And we evaluate using .evaluate. And we put test images. So how good our model works on test data, test labels, okay? And I think we can do classification. So let's do a prediction as well. Let's call it, because we have the shoes training set, let's define classification, which is going to be a prediction. Predict. We use predict to predict whether any of these test images, what category does these test images belong to? Okay, let's run this program. And we have a arrow, mod compile, optimizer. Okay. Still narrow. Okay. Now we need to wait 5 epochs. And we now see the loss. It's calculated 0.5, 0.3. So it tries to minimize it. You see here, 0.34. It step by step decreases 0.29. And the accuracy here is not so great. So it's about like on average 85 or 6 maybe. And the evaluation of our model on the test, so the loss was equal to 0.3 and the accuracy is 0.87, which is almost the same as for the training data, right? Any questions on this algorithm? Now let's do the some exercises to understand more what we did here. First of all, what if we remove the flatten? So you could use it like this, it would also work. So what if we remove this layer? Could you try on your computer and tell me what are the results? So what you have, if you delete this layer, we have an arrow. One thing is, there is a rule that the first layer of our neural network, so this was the first layer, right? It should be of the same shape as our data. So our data is 28 by 28, and we need to convert it to the 784 by 1 by using the flatten method. Okay. Now, what happens if you increase the number of neurons, for example, to 500? Maybe I should have increased it by 1000. In theory, it should have increased the accuracy, but I don't see it that it has increased. Let's try bigger number. Okay, that if you have something is wrong in your case. Input TensorFlow, Keras dataset version list, load data. Okay. Training images, okay. Camel sequential, Keras layers, flatten, okay. Dense activation ReLU, dense, okay. Model compile optimizer. Yeah, because here I have made a mistake. So please look at this line, and you need to write tf.keras.optimizers.atom, and in your case it's optimizers without dot, and maybe that will solve your problem. So we see here that the training was a bit longer, right? The accuracy wasn't increased so far. Maybe it's because of the data set. It's quite old, I think. Let's put the initial value, and let's try to change the value of another layer, which was 10, and let's try 5, for example. And we will have a error. This is because there is another rule. The number of neurons in the last layer should match the number of classes that we classifying for. Initially, I said that the dataset that we are working with consists of 10 categories, and that's why we put to the last layer number 10. And this is just a rule that we have to have equal number of the neurons in the final layer as the number of categories we are classifying for. Okay. And I think that's the main thing for today. And this is the simple algorithm that you can try yourself. You can load any data. Actually, next session, I want to show you different ways you can create image datasets and use this classification, for example, algorithm on it. So there are different ways. And I think that's it. Do you have any question regarding this? And by the way, this is part 1. So we have 2 more parts to cover regarding this topic.
Done.
Excuse me?
No, it's running. Now running that epochs 5 times.
Okay. By the way, if you also try to run it with more epochs, like 500, so it was 5 right now. Let's try 500, and it will, of course, take lots of time. But let's see the accuracy. Okay, so we can see here already that if we increase the number of epochs, the accuracy increases, right? And
Yeah.
when we try like 500 of epochs, it's a bit, it's too long to wait until it finishes. And maybe we are satisfied with 95% of accuracy. Then we can use the callback actually function. And I think I will stop when it's going to be 0.95. And I will explain, I think I will use I think there was not this. It's almost, no. Okay, let me stop. Can I stop it? Yes, I can. Oh no. Okay, I need, okay. So there is a callback function, and I think now it's 4 minutes, but I want to show you how to stop the program when you reach, for example, 95% accuracy. No, not this one. Okay. So this is what we can use. Let's try on our data. So we will define it here. Oh no. Okay. And we will add to our fitting data the callback. Okay. Fit data. And let's run it. No. There are some mistakes. Oh, maybe because I have stopped it and it. Okay, let's run this program here. How many epochs? It's 5. Okay, the same mistake. So what I wanted to explain here is when we add the callback function, we define it here and we say if the accuracy is now more than 0.9, or we can say 0.95, for example, then we stop our model training. So we define the model stop training true, and when our model fit, so it doesn't reach 500 epochs unless it hits the accuracy of more than 0.95. So this is the main message that I wanted to convey. Callback code, of course, I'll share it. Okay. And don't forget to add this callback to the model fit.
Yeah, I reached 96%, 0.96 accuracy.
Mm-hmm. So you reached and the program stopped, right?
No, it's still running up to 100. I use 100 epochs.
But you didn't use the callback, right?
No.
Yeah, but please try using the callbacks, and I think that might stop the program when you reach the desired accuracy.
Yes, I will try this.
Yeah. So this is the end of our study jam today. I hope to see you next week. See you. Bye-bye.
Bye-bye.